In this video, we're going to be featurizing our Airbnb dataset. First, we're going to be performing a train test split. This allows us to have two different subsets of our data, one that we'll be training our model on, and the second that we'll be using for evaluating how our model performs on unseen data. Afterwards, we're going to featurize our data by encoding categorical variables. Finally, we're going to wrap all of our different featurization steps into one pipeline, which allows us to abstract about all of the different stages in our featurization process a lot more easily. So let's perform our train test split. This makes sure that our model doesn't just memorize the data that we have, but that it can also perform well on unseen data. So here, I'm going to use this .randomSplit method that all data frames have. And now if we print out the counts, we'll see that we have a relatively small test data frame with about 950 records and a larger training data set that has about 3,800 records. We also set a seed, so that way if we run the same code again, we'll get the same values even though we're randomizing. Machine learning models are only as strong as the data that they're fed. Featurization is the process of creating the inputs for machine learning models. There are a number of different approaches to featurization. This includes encoding categorical variables, normalizing, creating new features, handling missing values, and binning values. Here, I'm going to use the string indexer that we saw in the last lesson, and I'm going to take all of my different categorical features and index them. Next, let's turn those indices into vectors. So here, I'm going to use the one-hot encoder estimator. Finally, I'm just going to define all of my different feature columns. Now I'm going to want to use this new function, vector assembler. What vector assembler allows me to do is take a number of different columns and combine them into a single vector. The way that Spark machine learning works is a little bit different from other systems. Machine learning in Spark operates on a single column rather than an array of different columns. And so vector assembler allows us to create just one column that consists of a vector of all the different values that we're going to want to train our machine learning model on. So now we've defined all the different stages of our pipeline. Here, we're coding a number of different categorical variables, we're one-hot encoding them, and we're assembling the results. Let's take a look at what our final data set looks like. Now, if we call .fit on our pipeline and pass in our data frame, we can take a look at what our final data set's going to look like. Here, if we scroll over to the right, we can see that we made this new column features, and it has an array of all of these different values. This is the one column that our machine learning model is going to be training on in the next video.